guys. So today we're focusing on addition with unequal denominators. So I'm going to be using my fraction strips here to show how to add fractions that have unequal denominators. So the first thing I need to do is I need to read my question. So on page 195 of the book, we see that Hillary is using red fabric to make a tote bag, and she uses one piece that is half a yard long. I also see that she uses another piece that is 1/4 a yard long. So I need to find my two fractions here because I need to figure out how much red fabric she used. So I'm going to use this one hole to kind of mark where I'm at and where I'm starting from, okay? So using that, I'm going to line up my 1/2 underneath it, and then my 1/4. I'm putting them side by side because in this case, I am going to be adding. So on my next video, we'll be talking about subtraction, and the subtraction will be a little bit different. We won't have them side by side. The subtraction will have it underneath, and I'm going to be finding the distance, the difference, right? So it'll be the distance that is not there, or in between, right? So I have this. So now I need to use these fraction strips to find my different denominator because I can't add 1/2 and 1/4 like this. I have to find something different. I have to find a similar denominator in order to add my two fractions. So in this case, I know that 2 and 4 are related, right? If I multiply 2 times 2, I would get 4. I also know that 2/4 make up 1/2. And I can even show that by putting them underneath my 1/2. So in total, I have how many fourths? 3/4, right? 1, 2, and 3 in order to add up to my total. So on my page, I will be writing 2/4 plus 1/4 is going to equal my 3/4. So she adds together to get 3/4 yards of fabric. So now I'm going to ask some questions. So how do I determine what fraction strips I use whenever I use a different set of numbers? So for example, I'm going to be looking at 1/2 and 1/3. So I have 1/2 and 1/3. I'm adding them together. So the first thing I should do is I need to look and see if there's any numbers that I can use to add up all the way across here. And I need to start with the largest strip. So I need to find the one that's largest. So I already know that 1/2 and 1/3 are not going to be ones that I use. So I can go and I can look at 1/4 perhaps. 1/4 isn't one of the next biggest one. So if I line them all up, I see that this is going to be short of what I need. And I need it to line up exactly. So I'm going to move on to the next step. I'm going to try 1/5. Whenever I try 1/5, I'm going to be just short of what I need. Just short of it. It's too little. I need it to match up exactly. So next I'm going to try 1/6. Something I noticed is that not only does it match up evenly with my answer, but not only that, it also matches up evenly with half and 1/3. 1/2 is equal to 3/6. 1/3 is equal to 2/6. And whenever I add them together, I end up with 5/6. So whenever I do this, I have to remember, whenever I'm using fraction strips, I start with the largest fraction strip possible. And I line it up underneath to see how many total, and it has to measure up evenly with my two addends. I can't just put it up there and expect something to be different. I have to make sure they are exactly the same. Because whenever I look at the math, I will see why this works. For example, I see 3/6. I know that 3/6 is equal to 1/2 because the number 3, my numerator, is half of my denominator, which is 6. And then same thing here. I know that 2/6, I know that 2 is 1/3 of 6. So then what the difference is here, the difference between the two problems that we just did, 2/4 plus 1/4 and 1/2 and 1/3. 1/2 and 1/4 was pretty straightforward, right? I used the same denominator for one of my answers. Right, so I had 1/4 and 1/2, right? And I used the same denominator as one of my addends. Whereas for this one right here, I used a factor of my new denominator. I used a factor of it, right? So I can list as many common factors as I want to. So I instructed the kids today that you can find common factors by listing them out. What is 1 times 2? What's 2 times 2? What's 3 times 2? What's 4 times 2? And listing them all out so that they see all of the factors that they could possibly have as a common denominator. And also listing out 1 times 3, 2 times 3, 3 times 3, 4 times 3. And that will help me to find my common denominator. And there are going to be multiples of these things. For example, if you even look at just these right here, I know that 1/6 is made up of 2/12. And I could do those all the way across the bottom here and show the exact same thing, that it is equal. And I could use 12 as my denominator. But the least common denominator is going to be that 1/6. And whenever I use that common denominator at the smallest amount, I will less likely needing to simplify my fractions in the end. So next, I can do, let's do 3/5. I'm going to do 3/5. Plus 1/2. So the first thing that I notice is that my answer is going to be more than 1 because my fraction strip shows that 1/2 goes past my 1/2. So I know my answer is going to probably end up in an improper fraction, which will then have to change into a mixed number. So I see 3/5 and I see 1/2, and I wonder what common factors am I going to find that will fit on both of these and add up to what I need to. So I look at the numbers I have, use my fraction strips. I have 8, I have 1/8, I have 1/12, I have 1/10, 1/3, 1/4, 1/3. I can look, right, and I can start with my largest one, and I can see, well, 1/2. I could try and do that, but it's not going to be enough. It's not going to measure up quite like I want it to. Then I can go to 1/3. That's the next largest fraction strip. Do 1/3, third, third. And I'm still not getting to where I want to be. It's too small. It's not enough to measure up to my two addends. So then I go to fourths. still not getting to where I need to be. I have to keep going. But I know that I can't use 1/5 to get to 1/2 because 1/5 is odd and 1/2 is even. So my denominator would have to be an even number. So I'll skip a look at 8. I can try 8 all the way across. I realize that it's going to go just slightly over where I need to be. So I'm going to go up one more to 1/10. I think that 10 might be a reasonable number because 10 is a product of both 5 and 2. Because if I multiply 5 times 2, I get 10. And I think that's a reasonable denominator for what I'm doing. And so if I added just one more, it would be exactly equal to what I need. So I add them up. Why? See, look, I have 2/10 for every 1/5. And then I also have 5/10 for 1/2. So I would change both of those into each individual thing. So for 3/5, if 1/5 was 2/10, then 3 of those fifths will be equal to 2 or 6/10. So in my book, I will be writing 3/5 is equal to 6/10. And 1/2 I know is equal to 5/10 because half of 10 is 5. So then I will have to add those two numbers together. I'll move my book into where you can see it. 6/10 plus 5/10. Now I have like denominators. And my denominator doesn't change whenever I add. So I would write 6 plus 5 is 11. 11/10, or changing it to a mixed number is 1. I know that 11 minus 10, that's 1/10. So I see that these two numbers are reasonable because, yes, it went over just barely on my fraction bar, right? So that means that my number being a mixed number or an improper fraction makes sense because it is more than 1. So let's look at 1 and 2 on the share. So it already has my fraction bars here for me. I don't have to do anything crazy. So 1 whole, and then I have 1/2 and 1/8, right? 3/8 here. So I need to find a common denominator for these two numbers. Well, I know that 2 and 8 are related. 2 and 8, I can multiply 2 times 4 to get the answer 8. So I only need to change 1/2. 1/2 will have to be changed so that my denominator is equal to 8. And to do so, I have to multiply that number, both the denominator and the numerator, by 4. So I'll apply 2 times 4 and 1 times 4, which will give me 4/8. And then I'm adding that to 3/8. I didn't have to do anything to my second number. So now I add 4 plus 3, which gives me 7/8. This is a reasonable answer because if I look at my fraction bars, my fraction strips, I see that my number is less than 1, and so is my fraction. So I'll move on to number 2. On number 2, I see that my add-ins are going to add up to more than 1 whole. then that means that my two numbers are going to be an improper fraction or a mixed number, right? I'm going to have that as my answer. Whenever I say that I need it in my simplest form, that means I need to write it as a mixed number and in the smallest mixed number. So I see, 4 and 3. I don't think I can use one of the numbers I have, one of the denominators I have, in order to use that as my common denominator. So what I'm going to do is I'm going to look at the common factors of 4 and 3. So I see 1 times 4, and that gives me 4. 2 times 4 gives me 8. 3 times 4 gives me 12. Interesting. I see a 3 and a 4, and I see 12. I might keep that in consideration whenever I look at the 3s. 1 times 3 equals 3. 2 times 3 equals 6. 3 times 3 equals 9. 4 times 3 equals 12. And I notice that the first number that I get whenever I multiply out and I see what numbers they have in common is 12. That's going to be the best number I need to use. So I'm going to put 12 as my denominator. But how do I get to 12 as a denominator with 3/4 and 1/3? Remember, I have to multiply. 4 times 3 will give me 12. That means I have to multiply my numerator also by 3, giving me 9/12. Then 3, I have to multiply 3 times 4 to get 12. So I have to multiply 1 times 4 to get 4. So I add them together. 9 plus 4, 13 over 12. However, I cannot leave it as an improper fraction. I need to create a mixed number. In this case, I have 1 and 1, 12, because 12 is just 1, 13 is just 1 more than, 13 is just one more than 12, meaning I have 1 and 1/12 as my answer. So moving on, I'll do number 3. There's 3 through 5. And then I'll look at some more problems. So I see here, it says to use fraction strips to find my sum, and then write it in my simplest form. So I'm going to pull out my fraction strips. Fraction strips are available wherever learning materials are sold, and also you can use online free manipulatives almost anywhere. So I would take advantage of both of those tools that you can use. And I will allow your students to use these as they need to during a test if they so desire. So I have 1 whole, and I have 2/5 and 3/10. So remember earlier that I used tenths to be equal with my fifths. I remember that there were 2/10 for every fifth. So I changed my fifths into tenths, and then I can add them all together because it makes it one equal denominator, which is 10. I have 1, 2, 3, 4, 5, 6, 7 tenths. That's my answer. 7 tenths is my answer, and I cannot simplify 7 tenths. 7 tenths is the smallest it can go. So now I'm going to move on to number 4. I have 1/4 plus 1/12. So I remember from just not even that long ago, I had a question where I had a 12 as my denominator. And also, a 4 was a part of the addends. So I remember that there are 3 12ths, 3 12ths that go into 1/4. So if I add them together, I get 3 plus 1. So I have 3 12ths plus 1/12, which gives me 4/12. However, 4/12 is a number that I can simplify. I know that 4 and 12 are related. Remember, there's 3 4s in 12. So if I divide both 4 and 12 by 4, if I divide both 4 and 12 by 4, I get 1/3. And if I show that here on my paper, or not my paper, but with my fraction strips, look, I see that that same information, that 4/12, is equal to 1/3. Just like I solved in my problem. So let's move on to number 5. I have 1/2 and 3/10. So if I'm using my reasonableness and I'm thinking about what numbers I know are related, I know that because this is an even number, my denominator is even in my 1/10, I can fit this denominator into 1/2. And half of 10 is 10. So I just set those underneath. And then I would add them together. So I have 5/10 plus 3/10, which is equal to 8/10. However, I know that 8/10 can be reduced even further. I know that both 8 and 10 are divisible by 2. So I'm going to divide both 8 and 10 by 2, which would give me 4/5, or 4/5. And I can even check that by looking at my fraction scripts. So if I put 4/5, I see that it is equal. And I can even shift these down to make sure. These are equal. So now talking about any kind of word problem. Let's look at the word problems that they list for us. Numbers 11 through 13. In a garden, bluebonnets occupy 7/10 of the garden, and after the winter, bluebonnets spread to cover another 1/5 of the garden. What fraction of the garden is now covered in bluebonnets? Well, I have 7/10 plus 1/5. I see that my denominators are not the same. But I also know that both of these denominators are related. I know that if I multiply 5 times 2, I would get 10. So I'm just going to change 1/5. I'm going to change it to 2/10. So then I would add 7/10 plus 2/10. My tenths stay the same. 7 plus 2 is 9. And I cannot simplify 9/10 any further. And I see that C is the correct answer. 1/5 wouldn't make sense because that's the same amount that got spread. I also know that 7/10 is more than half, so that doesn't make sense. And 8 would just be if we added incorrect. So now we look at number 12. So Elaine is using fraction strips to add 2/3 and 7/12. The sum is 1 whole plus how many 10? 12. So that means that my sum, I have 1. I have, say this is 2/3. And then I add 7/12. I number is going to go above 1. It tells me that my sum is 1 whole and additional 12. And that also gives me my denominator, my common denominator. So I need to make sure that both of my fractions have a 12 in the denominator. Well, 2/3 does not have that. And I know that I can multiply 3 times 4 to get 12. So that means that I have to multiply 2 times 4 to get 8. So then I will add 8 plus 7 is 15. 15 12ths. Well, I need to know how many additional 12ths than 1 whole. Right? So if I take this improper fraction and I change it into a mixed number, I get 1 whole. 15 minus 12 is 3. So then I have 3 12ths left over. I could reduce this and I could simplify this to something smaller than that, but it specifically asked for how many 12ths were left over. So I don't want to get that confused. I want to just stop where I was at. So let's look at number 13. Juan uses 1/5 liter of water to water a small plant, and he uses 1/2 liter to water a large plant. Juan has 2/10 liters left in the pitcher. How much water did Juan have in the beginning? So I'm adding all of these together because this is how much you watered the first time, this is how much you watered the second time, and he still had a remainder of this much. Now I see 3 different denominators. However, I know that all 3 of these denominators are related. In fact, it shows 5 times 2 equals 10, right? So I know that I need to make all of my denominators 10. Well, I don't have to change this one, but I do have to change these 2. I have to multiply 1/5 by 2 because 5 times 2 is 10. 1 times 2 is 2. So then I'll add what 1/2 is. So I have to multiply 2 times 5 to get 10, and 1 times 5 to get 10. Or sorry, 1 times 5 to get 5. Excuse me. So then I add 2/10 plus 5/10 plus 2/10. 2 plus 5 is 7. 7 plus 2 is 9. So I get 9/10 left over. The answer is 8. So the idea here is to be able to use these manipulatives in order to see visually how my adding my fraction looks and how I don't have equal things. Whenever I have these numbers, I can't add this with this because they aren't the same. They're not the same unit. It's like trying to add inches and centimeters, right? It's not the same unit. I have to use the same unit in order to be successful. So we have to understand that finding those common denominators, and in fact, we will actually work on specifically least common denominators, but finding those common factors and seeing those numbers and how they're related in order to change my denominator to match my equation.